Welcome back, lords and ladies. If you know a small bit about modern MBTs, then you will know that some are more symmetrical than others. But the focus of today's video is not the asymmetry of turret armor, turret placement, I'm looking at you, American Abrams, or even the storage containers themselves, no. We are looking at the asymmetry of the road wheels on the tanks. Now this is a question that a lot of people never have an answer for. The question I see a lot is, why are tanks' road wheels unevenly spaced apart? We'll answer that in the video soon. Now, if any of you have seen a tank before, you might have noticed that the road wheels are not in the same place on each side of the tank and different distances away from the drive sprocket itself. To help the people here who don't know as much about tanks, the road wheels on a tank are there to support the weight of the tank while it rolls over the track itself. Think about the wheels on your car. They take all the weight and divide it evenly between each wheel to make the vehicle balanced and move smoothly over the ground. Road wheels on a tank do the same thing, except they do not apply any forward or rearward force to move the tank. The drive sprocket is the thing that moves the tank and the tracks. So moving on to the main subject of the video, why on certain tanks are road wheels unevenly spaced and asymmetrical to the opposite side? There are three main reasons for this. To kick off the first reason, tanks are very heavy vehicles, as you guys know, often weighing well over 50 metric tons, meaning that they need heavy duty wheels to carry and spread this weight evenly. But I thought you said they were uneven. And they are, but this is due to the tank's weight being uneven. Tanks in their simple form carry heavy ammunition that is loaded into a big gun, a 120mm diameter for NATO guns, and a 125mm for Russian guns, usually, which is then fired upon a target. They also have to carry fuel, large power package, which hauls all of this weight to the battlefield at a decent pace. All of this weight inside the tank is never placed evenly, as more often than not we have two crew members on one side of the turret and one on the other side of the turret, these being the commander and gunner, along with the reloader on the opposite side, providing the tank isn't auto-loaded, of course. This being said, this means that the ammunition is placed on the same side of the chassis and turret as the reloader himself, for his convenience and quick gun loading, of course. This means other things have to be placed elsewhere in the tank, like fuel tanks, armor, optics, and other things. Because of all this uneven weight distribution and things being in different places and not symmetrical on each side, the road wheels on tanks are placed more frequently in areas of higher weight than they are in areas of lower weight, resulting in the uneven placement of the road wheels. This in turn means that the tracks on the tanks with offset road wheels are often at different vertical angles to each other looking from the front. Tanks are confined spaces with a lot going on inside them, with important components like crew, weapon systems, and even power packages with over 1,000 horsepower. So placing road wheels and suspension components at regular intervals could increase the space needed for the vital components, and even just outright get in the way of some of those said parts. There are a few different types of tank suspension, like the two famous ones, torsion bar, which was used on the infamous German Tigers of World War II and is even used in the armoured divisions of militaries today, and we have the Hautzman type, which was used again in World War II and after, all the way up to the Chieftain series of British MBT. Hautzman suspension being invented in Britain, it was mainly used on British tanks. That aside, all suspension types have their individual pros and cons, so trying to engineer something with all these options and requirements in mind must be an engineering nightmare. Spacing the road wheels unevenly can actually create a positive effect on the suspension ride smoothness. This is done to prevent vibration from building up as the tank drives over rough obstacles like rocks and uneven broken terrain. By spacing the wheels unevenly, impacts with obstacles are transmitted at irregular intervals into the tank suspension and chassis. This prevents oscillations from building up in the suspension system. Some faster tanks can start to rock badly on their suspension as they drive over obstacles at certain speeds, because the impact's spacing occurs at a rate close to its resonant frequency of the suspension system. Spacing the road wheels unevenly can prevent these rocking movements from building up by ensuring that such impacts occur irregularly rather than a steady rhythm. Anyways, thanks for watching guys, I hope you enjoyed the content in today's video. Don't forget to subscribe and hit that bell icon so you can stay up to date with all the video releases. Also don't forget to check out our Twitch channel and Patreon page to maybe get your name in the end of the next video. Thanks for watching, and I'll see you all in the next one.